But part A, estimate f prime of 4 and show all the work that leads to your answer. So in order to find f prime of 4, you have to do f of A minus f of B over A minus B, which is the mean value theorem. Okay. So then what we do is we plug in the two numbers that 4 is between. So then A is 5, and then we have B equal to 3. So 5 minus 3. And when we plug the values in, we get negative 2 minus 4 over 5 minus 3, which gives us negative 6 over 2, which is equal to negative 3. So then our answer is f prime of 4 equals negative 3. Part B, evaluate the integral from 2 to 13, parentheses 3 minus 5 f prime of x d of x. Show the work that leads you to your answer. So for this, we'll need to use the fundamental theorem of calculus, and then we have to expand this. And what we get after we expand is the integral from 2 to 13 of 3 d of x minus 5 times the integral from 2 to 13 of f prime of x d of x. And using the chart from before, when we substitute things in, what we get is 3 of 13 minus 2 minus 5 of f of 13 minus f of 2. And then what you do is you solve this, and then your answer that you will get will be 8. So the answer to 2, 13, 3 minus 5 f prime of x equals 8. Use a left Riemann sum with subintervals indicated by the data in the table to approximate the integral from 2 to 13 of f of x d of x. Show the work that leads to your answer. Okay, so essentially when we're doing algebra, what we have to do is we have a rectangle, and then each of these sides represents one of these points here. So since there are 5 sides, there will be 4 rectangles that we'll have to use. So the equation for a rectangle, as we all know, is base height. So then what we do is we just apply it here. We use the left side of the rectangles to find it. So then our equation that we'll have is f of 2, 3 minus 2, plus f of 3, 5 minus 3, plus f of 5, 8 minus 5, plus f of 8, 13 minus 8. So what we do is just plug it in, so we get 1 plus 4 times 2 plus negative 2 times 3 plus 3 times 5. And then what we do is after you do all the math and you work it out, the answer you'll get is 18. So using L-RAN approximation to find the integral from 2 to 13 of f of x d of x, the answer we'll get is 18. Tangent to the graph of f at x equals 5 to show that f of 7 is less than or equal to 4. Okay, so since they let you know that in the problem f prime of 5 equals 3, and from the chart you can tell that f of 5 equals negative 2. The tangent equation that you get for this problem is y minus 2 equals 3x minus 5. And then what you can do is you can bring the 2 to the other side to get, plus. You get y equals 3x minus 5 minus 2. And what you're trying to prove essentially here is that f of 7 is less than or equal to 4. So what you do is you just plug it into this equation, and if it proves to be correct, and then you can show that the f of 7 is less than or equal to 4. So what you do is you substitute y for 4 to get 4, and then you do 3, 7 minus 5 minus 2. So you do 4, 3, 2, minus 2, you get 6 here, minus 2, and then you get 4 here. And since 4 is greater than or equal to 4, it shows that f of 7 is less than or equal to 4. Use the secant line for the graph of f on 5, the domain of 5, 8, to show that f of 7 is greater or equal to 4/3. So since we know that the secant line, the slope for the secant line is actually just the negative reciprocal for the tangent, the equation we get is y minus 2 equals 5/3 x minus 5. So what we'll do again is we'll just bring the 2 to the other side, plus equal to 5/3 x minus 5 minus 2. So what we did before, what we do is we'll just plug this in here. So what we'll do is we'll have 4/3 is less than or equal to x 7 minus 5 minus 2. And then we get 5/3, 2 minus 2, this equals 10/3 minus 2, which also then equals 4/3. And then we get 4/3 is less than or equal to 4/3, which is a correct statement, which proves that f of 7 is greater or equal to 4/3.